Hi, welcome to this Hopsworks Demo Day. So people are starting to drop in. Today I'm going to present, I'm going to walk through building a loan approval machine learning system. We're going to build a complete machine learning system from the raw data. We're going to create features from the raw data. We're going to train a model with that, with the features and labels. We're going to build an inference pipeline to make predictions with new data that comes in. And we're going to put a little UI in. So we're going to do it all in about 45 minutes. Now, let's go through what we're going to do today. We're going to build a machine learning system. If you want to call it a prediction service, it's going to make predictions. And we're going to start from the very start. What is the business problem that we would like to solve? What are the business KPIs? Where will the data come from? Can we build a minimal viable prediction service? And how do we do that? We're going to go through 3 different steps and write 3 different programs today. One is a feature pipeline, which will create features from the loan approval data. We're going to train a model to predict whether a particular loan should be approved or not. And then we're going to have a user interface where I can put information about a new loan in, and then the model will predict whether that loan should be approved or not. That's the prediction consumer. So this is the iterative process that you can follow to build machine learning systems. Now today, it's an interactive machine learning system we're building. The pipelines feeding it will be batch pipelines. We'll get into that in a second, what that means. But let's first start at the beginning, which is what is the business problem we're solving? So the business problem we're solving is predicting whether a given loan should be approved or not. So a user will go to a peer-to-peer lending platform like Lending Club. That's the world's biggest peer-to-peer lending platform. They make a lot of their data about the loans that they've issued public, which is great. And they actually update them once a month. So in fact, the code we're going to look at today, you can run on a schedule once a month, and it will pick up the new loan information that's been published by Lending Club, and then it will keep updating. So we're going to write programs. The idea is to write pipelines that keep running. Not going to work with static data. This pipeline should keep running and keep pulling in the new Lending Club data, and you'll be able to iteratively improve your model with the new data that becomes available, and then make better predictions over time. Okay, so I said already we're going to write 3 different programs. The 3 programs that make up our ML system, they're what people often call pipelines, ML pipelines. Now, ML pipeline is an ill-defined term. It's not very clear what an ML pipeline is. And we find that dividing them into 3 different pipelines, a feature pipeline, a training pipeline, and inference pipeline, makes much more clear what the responsibilities of these different programs are. So the first program is the feature pipeline. It's going to take the Lending Club data, and it's going to transform it into features and labels. We're going to train a supervised machine learning problem, so we'll need labels, the targets of our predictions. And with the features and labels, we can write a training pipeline. It's going to be a separate program. These will be notebooks. And then finally, we'll have so the training pipeline will also save a model. We're going to save the model as an output. And then the inference pipeline will take the model as input and new feature data. And the feature data could come either from a batch pipeline, or it could come from the user interface. But we're going to make predictions with these new features. So that's the 3 steps we're going to go through. We're going to join up those pipelines using Hopsworks. Hopsworks is the platform that I'm presenting today as the kind of underlying infrastructure. The main idea with Hopsworks here is that you don't have to build this infrastructure to build ML systems. You don't have to build a shared data layer between the pipelines. You don't have to have somewhere to store and manage your features or your models. All that is done for you. You need to just work on building the machine learning system. So the feature pipeline we're going to work with pandas data frames. So we're going to take the raw data as CSV files. We're going to read them up as pandas data frames and write those data frames to Hopsworks. That's our feature pipeline. Our training pipeline will read up the training data as data frames. We'll train a model, and then the model will be saved back to Hopsworks as a pickled Python object. And then finally, we'll read that or download that model in our inference pipeline, and we'll get new data for predictions, either from the user interface or from a batch inference program, a program that could run to maybe generate a dashboard on statistics on the model. We're not going to concentrate on that, but that's another use case of machine learning you could have for this data set. Tell me about the risk level in my portfolio, and you can see how many loans are at high risk versus are steady. And that would be another machine learning problem or prediction problem you could use on this data set. We're not going to go through that, but it just shows you the power of the architecture we have. You can easily plug in different prediction services into this architecture. That's what we're going to do. The data itself, we have one table which is related to loans. We can see here that the loans has an entity ID. The ID here is, remember, it's a peer-to-peer lending data set. We have the ID of the user, and the user can apply for more than one loan. So maybe this user 122 applied for a loan on the 1st of January 2022, and also applied again the 1st of October 2022. And when the user applies for a loan, there's an interest rate. They have to specify the purpose of the loan. Obviously, they want an amount they want to loan. And then finally, when a loan has been, let's say, finished, it can be finished and be fully paid, or charged off, which is not so good. Charged off means that there was a default on the loan. So you can see that this loan status, this is the column that we'd like to use as our target, right? This is the label we'd like to predict. So this is historical data, and because these loans have been completed, we do have the status of them as paid off, fully paid, or defaulted, which is called charged off. Now, there's another table which is features related to the people applying for the loan. So the ID here is the same ID we had in the previous loans table, but in this case, we can see that it's information about the applicant, the person applying for the loan. So we've got the earliest credit time for the user. We're calling this a credit. This is the event time. I haven't discussed these different column types. We can see with event entity ID, that's the primary key effectively of this table. We're calling the table a feature group in Hopsworks. And then the event time is the observation time for the event. In this case, it's a change in the applicant information. So maybe the application's verification status, not verified. And then maybe at a later point in time, they'll get verified, and we can have a new row in here. It'll be the same entity ID, but a different, maybe the earliest credit line time will change. And then home ownership, does the person own a mortgage or not? Do they they own the home? Maybe they rent. And then annual income. So these are features that are used to help predict whether we should approve a loan for an applicant or not. From a Hopsworks perspective, we saw on the previous slide, we had this column, the ID column is our entity ID or primary key. We have this event time. So you can have multiple events with the same entity ID, and then the unique ID for each row then becomes a combination of the ID column and the issue date column here. The issue D is the issue date for the loan. Individual cells in this table are feature values. So these are features: interest rate, purpose, loan amount, and then a collection of features related to a particular label is what we call a feature vector. So you can see we have these three features, and this is our label. But we're going to actually join features or columns from this table with the applicants table, and that will be our richer set of features, the feature vectors that we're going to actually use to train the model. So the data sources themselves, these are the loan information coming from Lending Club. They're released monthly. So there's a lot of CSV files. I'm not going to go through all of them, but the program that you write could pick those up from maybe a source such as a bucket in S3 or a URL where the data gets published, and you'll just need to run your feature pipeline program once a month to get the new data, and we're going to write that data then to tables or feature groups in Hopsworks. And those tables will be incremental tables. We're going to, every time we run and add more data, we're going to incrementally add that data to those tables. So we're not going to drop the tables and recreate them. We're going to do incremental tables or feature groups. We're not going to go into the details of some of the features that Hopsworks provides, but just one to point out is that when we create training data, there is a risk of having what's called data leakage when you have the loan status. This is our target column, and we'd like to join in the features. So what was, for example, the home ownership feature value at the time the user applied for the loan? Did they own a home, or did they maybe rent, or did they have a mortgage? You know, if the user updates their status over time, maybe they were renting and now they own a home, you don't want to take, if the point in time when the loan was approved, the user was renting, you don't want to pull in a later value for the user and say, well, they own a home, because that would be future data leakage. So that's something that's handled automatically, but it's not something we'll go into too much detail. Now, the 3 programs we're going to write are the loan approval feature pipeline, the training pipeline, and the batch inference pipeline, and also this app.py, the user interface. So that's the 3 programs. You can orchestrate them. We're not going to go into too much detail today about how to orchestrate them, but there is information about how to run these pipelines on a schedule with a framework like Modal. You can, of course, do it within Hopsworks itself. This is the URL to the GitHub repo, and I'm going to clone that. I've already cloned it, but we'll show you how to do that in a second. But to get started, the first thing to do is get a Hopsworks cluster. Now, I have one already. If you don't have one, go to app.hopsworks.ai, click on sign up. You can register with Gmail account or your own email address. You'll have to then validate the email. And then when you validate the email and enter the name for your project, you'll have to enter a name for a project on hopsworks.ai. Then you will have a project with that name. It is a global namespace, so if somebody has already selected that name, you won't be able to take the same name that somebody else has. So don't just call it test. I'm sure that's gone. There's about over 3,000 projects on this serverless feature store platform. So pick a unique name that you think nobody else will have. The second thing you'll need to do is create an API key, and I'll go and show you how to do that now. And you know, registering on the platform is not too hard. We can kind of see this is what you need to do here. You can see you've got login up here on hopsworks.ai. This will bring us to app.hopsworks.ai. I'm already logged in, so it's going to log me in already, but that's where you would register from. Okay, so let's close that. So now let's assume I've come into Hopsworks. This is what Hopsworks looks like. You can see I called my project live demo, and you won't have very much in here. I was playing around with it earlier. I created some feature groups. I deleted them. But let's create an API key again, just to see how we do it. We're going to go to account settings, and you can see we have some different options: profile, authentication, APIs where we want to go to, and we can create a new API key. So you give your API key a name, and we'll call this live demo. And you can, these are the set of privileges that your API key has, a set of things that you can do. This typically should work. But maybe if you want to, you know, use some of the more exotic parts of the API, maybe you want to install a Python library from your Jupyter notebook, then you'll have to enable this, for example. So let's go ahead and create the API key, and we can save this. So to save it, you press the copy button here. And what I would do typically at this point, hopefully you can see my screen, is I would write, if I'm working from a notebook on your laptop, and you could do this from Colab, of course. I like to work from a notebook. I'll do the following. I'll create a shell script to set my environment variables. So I'll go something like vi set env for hopsworks.sh, and then we'll call it /bin/bash, and then we'll go export Hopsworks API key equals the API key that I just created. I'm going to delete that in a second, so you don't need to worry about it. We'll make that file executable, and then we'll call that script, and now you'll see that that API key is set. Okay, so we can see, for example, so I have some other environment variables set there, but it's enough on Hopsworks AI just to set that particular environment variable. Now, I have another one that I set here, which I'm going to change for my actual application, because that API key that I used, I'm not going to use. I'm going to delete it actually straight away. So I don't need that. So we can just delete that one because I have one already. Delete API key. Okay, right. Now let's go back and see where we're going to start. We're going to start at the code. So this is the code here. It's called Hopsworks Tutorials, and there's a folder inside it called Loan Approval that we can see here. There are many different examples in here that you can go through. The Loan Approval one is interesting because we build a complete machine learning system. We have a feature pipeline. We have we have EDA. I'm going to skip the EDA today. EDA is exploratory data analysis, where you can go through and examine the data set. we're going to skip that today. We're just going to go straight to building the feature pipeline, the training pipeline. We'll also look at what a batch inference pipeline, so making batch prediction requests is, but the real key is then the ML system I want to show you is the user interface, which is app.py, and that's a Gradio application. Gradio is a Python-based framework for building user interfaces. You don't need to write JavaScript here to get a nice UI. We can see also that there are some libraries to install: Hopsworks, JobLib, and scikit-learn. So we'll need to install those. So typically the way I would start is I would use a Conda environment. And I actually have one already. I'm sorry, I need to move down a little bit here because Conda activate hops. And I've already pip installed. So you want to pip install Hopsworks. Now I've already installed it, so I'm not going to run this again. And then you want to do also the same for scikit-learn. And then you press return, and then JobLib. So JobLib is a library that's used to serialize your models and to deserialize them. So in my case, we have a look at the versions. Pip show Hopsworks. I'm using 1.3, I believe, of Hopsworks. So sorry, 1.3, 3.3. You'll probably get 3.2 if you're using Hopsworks today. It'll be upgraded shortly to 3.3. 3.3 gives me a lot better performance when reading data through Python, which I like. Scikit-learn, I believe, is 1.1. You don't have to use this version 1.1. I'm using it because I'm going to run some notebooks within Hopsworks. And then JobLib is 1.2, if I believe. Yeah, 1.2.0. But of course, you can work with different version of scikit-learn and different version of JobLib. But what's very important is that you have the same version of JobLib and scikit-learn in your training and inference pipelines. Because if you have a different major version of JobLib or scikit-learn in the training and inference pipelines, then you may have problems. Okay, we want to clone that repo, and I cloned it already. Git, let's have a look. Git, Control-R, Git clone. So this is what I ran before. And I have it's going to take a while. It's a couple hundred megabytes, I think it's going to download. So it takes a little bit of time. And then loan approval is my where my notebooks are. Now, Hopsworks itself, if you're curious, not on the AI version, but we actually have notebooks here. And I'm going to play with the notebooks in Hopsworks. It's just the same as running on your own laptop. I just like it. It's a little bit faster. So it's going to be faster for writing the data because the notebook is within the same region in the cloud as Hopsworks, rather than from my home internet connection. But let's go ahead and look at the notebook. So I'm going to go to this one, the loan approval. If you're using Hopsworks, this version of Hopsworks, this is the managed version where it's running on my own cloud account. You will. I did already clone this repo, so you can see here I can clone the repo. So I went to GitHub and you paste in then the URL from the GitHub repo, and I did. The libraries are already installed, so the base image already here has Hopsworks, and we have scikit-learn here as well, and we have JobLib, so they're already in here. Okay, but if you're running on your laptop or in Colab, you just need to make sure those libraries are available. Okay, so I'm starting a notebook, and the notebook has, a couple of gigabytes of memory, I think, not too much. Let's have a look. So the code that you'll see, you can see it says pip install here. I've already done that. I don't need to run that cell. If you're in Colab, you'll need to run that cell. And this is again for Colab. So Colab is a bit finicky here. What's actually going to happen in the notebook is I'm going to put my features in this directory or package. So we've got a package called features. And I'm going to create two tables of features, one called applicants, one called loans, we talked about already. And the logic to compute them will be functions. So I'm going to take pandas data frame. Let's have a look at loans, for example. We've got one function here. From the loans table, I'm going to compute zip code. So when I pass in the address, I'm going to basically take that address. We're going to cast it to an int. We're going to look at the length of the zip code. And if it's 5, we'll return and say it's a valid zip code, otherwise it returns 0. So it's not a very complex feature. But the issue in Colab is that if you clone this in Colab, it's slightly problematic. So what's happening here, it's just downloading the this Python file, these two Python files locally in Colab. But in general, if you're running on your laptop, this code will just get skipped. Okay. So we can run it because I have to set the today's date. So it's going to download this today's date. You would typically pass as a parameter when you run this as a pipeline. That would be the, in this case, the date of the loan approval data that I'm going to read. This is going to be a parameter to reading the files with the correct date, the loan approval date. Okay, so let's work through the code. We're going to start by importing pandas and NumPy. This is where we're going to get our loan approval data from. The loans data set, you can see we're passing in today's date. So this is from a URL. Like I mentioned before, today's date is not defined, so we do have to run this cell. I obviously skip that cell. So now we'll run that cell. And you can see it's downloaded this. Now I think this is, it's over 100 megabytes of data, I believe, as a CSV file. The Parquet file is a bit smaller. It's maybe 20 megs or 15 megs. But it might take you a little bit more time than it took me. Now, what we're going to start doing with this data set, the loans data set, you can see we have a bunch of, if we look at it, we can see we have a bunch of columns here. And these are the ones that I introduced already. We have the loan amount, the ID of the user, the interest rate, the term, and you can see it's a categorical variable. We have many numerical variables here. The grade of the loan, the subgrade, the issue date, the loan status, the purpose of the loan, the title of the loan, and then the address of the person who's applying for the loan. So what we're going to do to start out with here is just get the month, loans month. So let's have a look at this. It's going to go through the entire data frame, and then we'll have a look at it after that's been computed. We can have a quick look at the you know, in this case, we can look at the descriptive statistics over the numerical features in the data set as well. That's what we're doing with describe here. It's not strictly necessary. This is just to give you a feel for the interest rate, the distribution of values, and the same with the installments and the amount. You can see that, you know, the average loan size is 14,000. The mean is 14,000. We have 396,000 rows and 30 rows. Pandas is reading up the Parquet file. It's important that we have the correct data types for the columns. We can see we have a lot of string columns. Here's object. We have the three numerical columns are float 64, and then the ID column, this is going to be our primary key for the feature group or table that we create, is int 64. So we haven't done too much there. We're just looking at the data a little bit. Let's read up the applicant's data and have a quick look at that. So the applicants, again, have an ID. That's at the very end here. We can see the ID over here. And then we can see a lot more information about them. Employment title, employment length, home ownership, annual income. We've I'm not going to go through all of them, but they're basically information or features which help have predictive power for whether a user should be approved for a loan or not. Here we're just checking to see if all of the earliest credit times are unique and getting the month for those. So let's have a quick look at the data types again. Just a little bit of EDA here. And we'll get into feature engineering then. So you can see it's not like super fast because this is pandas 1.x, not pandas 2x. And we have a reasonable amount of data, you know, 100 megs if it was CSV file. So let's run feature engineering. We're going to, the first thing we're going to do here is we're going to run this home ownership. We had a look at this function already. So this is what we call a feature function. What we do is we take our data frame and we take the home ownership column. That's this column here. You can see we've got home ownership here, and here we have home ownership here. And we're going to apply this function called applicants.homeownership. So let's have a look at that function. So here's the function, applicants home ownership, and all it's doing is saying if the home ownership string is equal to any, or if it's equal to none, we're going to set it to other. So it's really just cleaning up the data so that we don't have too many categories. And then we're updating our home ownership column. It's going to print out then just the start time, end time, which is just to see how long it took. We've done that, not that long, of course, and we can see the different categories that we have now. We've got mortgage, rent are similar enough in size. Own is you know, about quarter of the rent size, and other 146. Now, the next one we have is we can see if earliest credit line. Now, if we look at earliest credit line type here, we can see that it's a string. Now, we want to make that a date time column, so we're going to cast it here. And we do the same for issue date. So they're going to be what we call the event time columns in our feature groups. They'll be the observation times for the events. So we're gonna have to convert them to be date time columns. So in Hopsworks, a datetime, what we call the event column in a feature group, this is the column that is used to do what we call a point in time correct join. We talked about no data leakage earlier. And this is when you specify that column in a feature group, then our join APIs in Hopsworks know and are able to create what's called a query plan that ensures there's no data leakage for you. But you do have to provide that event time column, otherwise it won't be able to do that for you. So let's look at the next one. We have the applicants. We have a column called public_rec, and we're applying a function called public_rec. So let's have a look at that. Public rec, it's very simple. If the number is 0.0, we return a 0. Otherwise, we return a 1. And then we're applying another feature function here called public_rec_bankruptcies. And we can see that's this one here. Again, it's a form of normalizing the numerical data, or homogenizing, I should say, rather than normalizing. Let's not be incorrect. We're cleaning up a little bit, removing some of the columns that are not particularly useful. And you can see we're getting a little warning here. That's just because we can clean up our code to cast them to the correct type. It's not a problem. And then we have another feature here called the mort ac, which is mortality, I guess. I'm not 100% sure, but I guess it's the mortality of the account. Let's have a look. It's in applicants fill mort. And we can see here that mort is mortgage, I'm sure, actually here, I guess. So we're basically saying if the number coming in is not a number, then we're going to impute a value. So the total account average, and we'll impute that value. Otherwise, we'll return the actual value. So a little bit of data cleaning. And then we'll remove some missing values in the applicants, remove the rows with some missing values. And now we're going to do a little bit of work with the categorical values, clean up some of the features we don't need. We looked at the zip code feature earlier. Just have a quick look at the data types, make sure they're okay. And this is slightly different. Now we're getting into, I'm going to change this number because I saw earlier that it was the range of interest rates in the data is not entirely correct. Some of them are negative. So what this is this is a data validation rule. And this data validation rule is going to say that the interest rate should be between -4 and 2,000. So we're going to look at all the values of interest rates in the table of about loans. And if the values are outside that range, we'll generate a warning. So now what I've done is this is very Hopsworks code. We're going to connect to Hopsworks, going to log in, get a reference to the feature store. If you're doing this in a notebook, if you set the environment variable Hopsworks API key, it will just work. You can, of course, pass that as a parameter. You should never include your API key in your code, although it's always best to have it as an environment variable. If you're running your own Hopsworks cluster, you'll also set Hopsworks_host here as the head node URL or IP address. And then also, if you have many projects in Hopsworks, you can put the Hopsworks project name in here. So I've got a reference to my feature store now for this project. And what I can do is I can create this table of features called loans. And what I'm passing in here, you can see is the name for the table or feature group, the version of it, the description of it, whether we're going to make those features available online or not, because if we have a real-time model, we need low latency access to it. Which column is the primary key? Which column is the event time? And then we talked already about these data validation rules. And this validation rule, which is making sure that interest rates are between -4.0 and 2,000. We can do the same for the applicants feature group. The only difference here is I've got a partition key column here that you can add if you want. I just commented out for the moment. If you have very large volumes of data, it's often very beneficial to have a partition key. It's not going to be a feature in your model, but enables you to query data. If you're querying data across a range of time, then you can push down filters to the actual offline store and retrieve only the data you need in that time range. And you don't need to read all of the data and filter it out. So the next thing we're going to do is we've created the feature groups. We haven't uploaded the data. So to upload the data, which is in our data frame, these are our features, we just call feature group.insert on the loans df. And you can see it's inserting the data. We can see it's uploading it here. And I'll start the next one running, which will run after this. And we're just seeing how long it takes. So it's going to take a few seconds. In this time, it's taking 22 seconds for, like we said, uncompressed about 100 megabytes of data. And we'll do the same upload for the applicant's data set. Now, there is in the repo some more metadata about the features. You can see this. Here are some of our features in the column loan stat new. We have descriptions of those. So we're going to actually get those descriptions and add them to the individual features. So this for loop here is going to download these set of metadata or descriptions of the features, and it's going to update those feature descriptions in our feature groups. So we can see what's going to happen there. Let's go back very quickly to Hopsworks and see what happened. So when we go to the feature groups here, we can see that our two data sets were created. There's no description of the features, so let's go back and run this code here, which will update our descriptions of the features. And we can see there's no description there. Let's go back and have a look at our second feature group. So our descriptions have come in here. What we can see in here are the features themselves, the types of them. So the offline type and online type. We can see also which columns are the event time column, which is the primary key column. What's your partition key? We don't have one here. We see how many features here, how many commits have been made. You can see it says 0 commits. And you think that's strange. I was uploading my data. But in fact, when you write to Hopsworks, the data will run an ingestion job. It's going to run this Spark ingestion job in Hopsworks to ingest the data. And you can see it's running here now. It takes about, this case, about 1.5 minutes for me. These will be finished very soon. You can see this one finished in 1 minute 32 seconds. And you know, that time is, a lot of it is the Spark startup time. The actual time to ingest the data is not too long. But if we look at the tables here now, we can see that I think it was the applicants one, was it, that completed? Let's have a quick look here. Okay, the jobs are finished. Okay, so this one finished. This is the loans feature group one is finished. Okay, so that's this one here. And if we refresh, we should see some data in here. Let's click on data preview. So yeah, we can see the data's in here now. So this is the online data. You can click offline as well. And that's going to go to the Parquet files. In this case, it's going to be stored as a Parquet table, a hoodie table. We can see that statistics were computed over the features as well. And we can see activity in here as well, that the data was run. Our data validation failed. So let's have a quick look at why it failed. You can see that if we click on here, we can see the view why it failed. And it'll tell us that there was evaluate expectations 1. Let's have a look. Okay, so okay, it says that I actually made a mistake. So the type of the values that I entered wasn't correct. We can skip over that. I shouldn't be playing around with it. Let's see what we made here. Yeah, this should have been actually an integer value rather than a string. So that was the mistake I made. I shouldn't play around with it, but if you run that again, it will be okay. So that's it with the ingesting the data. That's our feature pipeline. Let's move on to the training pipeline. And this is our training pipeline here. And the training pipeline, what it's going to do is we're going to use, if we look down further, we can see that the model we're going to train is, you can see down here, it's a scikit-learn logistic regression model. So, and we're going to use a scikit-learn pipeline to encode some of the feature values as well. So let's go back to the start and see what we're going to do. So that's what we're going to do in here. We're going to train a model, a logistic regression model in scikit-learn, and we're going to save it to the Hopsworks registry. So we have some imports in here, and that's fine. We're going to log into Hopsworks, same as before. Now we need to do is we need to select the features from our feature groups. So what we're doing here is we're actually selecting we're getting references to our two tables that we created, loans and applicants. We're now selecting all of the features except the primary key and the issue date or event time from the loans feature group. And then we're selecting all the features except the earliest credit line time, earliest credit line year, and ID from the applicants feature. So this query object is the selection of features. So what we want to do now is create the feature group, feature view, which are the selection of features that we're going to train our model with. And this line of code was written. So in fact, there's a newer API in Hopsworks which looks like this, which I would have written the code as, where you would call get or create. So this is actually better code. So this will be then idempotent. We'll run this code. If the feature view doesn't exist, it will create it. Otherwise, we'll get a reference to it. So that's the name of the feature group. The version is 1. The description, the target column is loan status, and then these are the selection of features that we're inputting. So once we have a feature view, we can create training data. And all you have to do to create training data is call a function such as train test split. It will give us a training set of features, a test set of features, a training set of labels, and a test set of labels. So these are data frames that we've gotten back. It was very quick. This is going to take you a little bit longer if you're not using the latest version of Hopsworks. We can see what this looks like. These are the set of all the features we're going to use to train our model with. We can see what the label is here. We're going to encode the categorical features and numerical features. And firstly, we just need to find out which particular features are numerical or categorical. That's what's happening here. We're getting an array of the categorical features and an array of the numerical features. And then we're going to use in this case, we're going to use a one-hot encoder for the categorical features. And for the numerical features, we're going to have an imputer to impute values with a median value. We're also going to standardize the numerical features in here. So this is the scikit-learn pipeline that's going to perform those model-specific transformations, the encodings of the feature values. And we're also going to encode the target column here. So we're doing that just by hand, turning it into a binary target. So either it's paid off, which is a 1, or charged off, which is a 0. So that's the little bit of work. We haven't computed new features. We've just done feature encoding and scaling. But now we'll have a look at training the model. So we've got our we've got our train set of features and labels, and you can see that it's starting to train. I think this takes about 20 or 30 seconds to train. So while it's training, I'll just go through the rest. We have also got back test set. So we can see the performance of the model in the test set by just taking the train model CLF and calling predict on the test features. This will give us our test predictions, and then we can compare those predictions, y test pred, with the actual labels. So what were the actual predicted values? So if we do it here, we'll see that the performance in our classification report, we get an F1 score of 0.62 for 0 and 94. So 0, if you remember up here, 0 was when we defaulted, and fully paid was 1. So we can see that it's more accurate for when a user will pay off than it is for when a user defaults. We can compute a confusion matrix and have a look at it. We can also save that with we'll save that confusion matrix with the model to the model registry. So I'm just going to jump ahead, and what we're doing here is basically saving or pickling our model into a file that we're going to upload to the model registry. So you can see that this is our trained model CLF, and what we're doing here is we've created a directory called lending model features, and we're saving just an image so that we can store that in our model registry as well. We can just see the rock curve of the model. And we're also saving the pickled Python object. So we're saying, okay, this CLF, which is our trained model object, we're going to save it into this pickled Python file. We compute the accuracy as well, because we're going to store this accuracy along with our model. So we have this, when we store the model in Hopsworks model registry, we need to firstly provide the input and output schema for the model. We take it from the data frames for features and for labels. So this could be X train and Y train, but we chose test here. It doesn't matter. And then we're going to create a scikit-learn model. We can see here's the name of it. These are the metrics. We're going to say this is the accuracy of the model. This is what we computed up here. And we give an input example so that if you want to actually deploy this model, you can test it. There'll be an input example that can be used automatically to test it. And then we say this is the schema for the model, and finally we save it. So if we go back to Hopsworks, we'll see that we have our feature view now. This is the loan approvals feature view. You can see in here that these are all the features. Some of them are coming from the loans feature group. Some of them are coming from the applicants feature group. We'll see that a training data set was created here. And we can see that here, and you can click in to get more details. We can see some provenance. Here's our feature view, which used to create this training data set. And the feature view came from these different feature groups. So the features came from there. So the model itself got stored here in the model registry. We can see it's our lending model version 1. You can have, of course, many versions of the models. And similarly, you can have many versions of your feature views and feature groups. And we can see here that this is the accuracy that I saved. And if you want to see the the image, the rock curve, you can go there, double click on it, and you'll be able to view that as well. So now we've got a model. Great. Let's move to the good stuff. Let's look at making predictions and inference pipeline. This is a very simple batch one. It's not the real one I want to look at, so I'm just going to run it quickly and we'll go through it. But basically, this batch prediction pipeline, what it's doing is it's getting some new feature data. So it's going to, we're going to get the feature view version, the model version, and some batch inference data. So I pass in a time range of data from when I start to when I finish. This is the Google Colab code. We'll skip over that again. We log into Hopsworks. We get a reference to our loan approvals. Now this time, instead of getting training data, we're going to get batch data. So we call feature view dot get batch data start time to end time. So it's going to give us, in a feature pipeline where new data gets written, we'll be able to then pull out that data and then score it. So make predictions with that range of new data that the feature pipeline wrote. So you can see here that I've got this batch data. It's a data frame. And I clicked on all the cells to run them. We download the model. Downloading the model basically means getting reference to the model registry, giving the name and version of the model. What it'll do is it'll download it to the local directory where this container is running, or this notebook in this case is running. And then we're going to use joblib to unpickle that model. So this is the model, then the unpickled model we'll get back here. Now, because I trained the model with a data frame, I can call predict on the data frame, and I get back my predictions. You can see the predictions here are just, whether the loan should be approved is a 1 and a 0 if it's not. And, I'm not going to do very much with this because this is not the app that I want. But what we can also show you here is I can also look at the accuracy of the prediction. So we can monitor the performance of it over time. So I can compare the predictions with the actual outcomes. So I'm creating another feature group called monitoring, and I'm just writing the monitoring results back there. But we won't go into too much details on that. But that's another nice way you can then look at the confusion matrix to see the performance of your model over time. How many did it predict to pay off versus how many actually paid off, and how many defaulted that you predicted defaulted, and how many defaulted where you predicted they would pay off. So it gives you a general idea of the performances. Let's look at the last program. This is our online inference pipeline. And this online inference pipeline is a Python program. You see, it's not a notebook. So I'm going to run it on my laptop. I'm not going to run it in Hopsworks. And I've made sure on my laptop that I have the correct versions of Python and so on. So let's have a look here. I'm just going to run Python -m app.py. I think we're in a little bit slow. Something the usual demo gods are here with me. So let me I see this seems to have crashed my Ubuntu. I'm using, oh, it finally came to life. So I'm running actually Windows subsystem. So let's have a look here. It seems to be going very slow again. Maybe I should create a new shell. Let's see if we are. So I go to projects, Hopsworks, tutorials, CD loan, and then we're going to go conda activate hops. Okay, and then we're going to set my API keys, which I do here, and then we go Python -m app.py. So this is just running the Python application. And what it's going to do here is first it's going to connect to Hopsworks, and you can see it took 1.8 seconds to do that. It's then the program is going to download the model. Let's look at the code. So it's going to run this code in order. So the next part we do is we download the model just like we did in the batch application, print out how long it took. Then we're going to get a reference to the feature view. And now we have a function called approve loan. Approve loan is, in fact, the user interface. Now, I'm not going to go through Gradio, but this is how we write a program in Gradio, a Python program with a user interface. And you can see here that these are the optional input values in the user interface that I create. We're going to have a label with the ID, the term of the loan, the purpose of the loan, the zip code that the applicant is coming from, the loan amount, and the interest rate. They're the only values I'm entering. There are many other values for the loan. They're going to be retrieved from the feature store. They're going to be the pre-computed values for the user, in this case with ID 111. So I filled in an example here because it makes it easier to use in the user interface, but it's basically going to call this function approve loan. So some of these features, these came in from the user interface. And some of those will need to be computed. This is what we call an on-demand feature function to compute it in the online inference pipeline. It's going to be consistent with the feature pipeline where we also compute pre-computed features. And finally, we're then going to say, give me back the feature vector with all the features I need to make a prediction. So we pass in the user ID. We'll get all of the features back from the feature view, except these ones, the past features that were computed in the user interface. So these are the ones I enter in the user interface. So let's have a look at the user interface. It should be up. This is it here. And if we go back here, we'll pull it up here. Okay, this is our user interface. It says loan approval. We have some details that we want to enter. I'm not going to enter them in by hand because the easiest way is just to click on this example here. And you can see these are the features that the user enters. And when I press submit, what's going to happen here is it's going to go to Hopsworks. You can see, and it took 3 seconds to download the data. It was a little bit slow because it was the first time, but the second time I run it, it'll be a lot faster. So we can see it takes 0.35 milliseconds. The first time was just establishing the connection. So that was then making the prediction. So it returned the prediction of whether the loan should be approved or not. And then I printed out this nice little diagram, whether it was approved or not. So it's a little JPEG that got shown on the screen. So I used the image library, PIL library in Python to do that. And that's it. That's the end-to-end example complete. This was our front end for our loan approval that people ask. We can see that it's connected into the feature store for the pre-computed features. We can compute some features in the online inference pipeline on demand. And now we have a machine learning system, a complete system where we write data in feature pipelines. We have a training pipeline to train our models. We have online inference pipeline to power this online application. You can have a batch inference pipeline for powering batch machine learning applications with dashboards. The next step you can do is to orchestrate them. Hopsworks has support for jobs, but if you have your own orchestrator like Airflow, or if you like a modern lightweight one like Modal, go for it. There's the next step is really running this as a system that runs every day. With that, I'll thank you for joining this demo day, and hopefully you can follow along. The video will be available where you can follow along at your own pace, and you'll be able to build example systems like this and show the value of your models to your stakeholders. Don't just show them an F1 score, show them an ML system. Thank you.